I actually prefer to use the clicker.
No.
Because then you end up touching the camera. There's obviously a problem with that because you end up adjusting the angle. Stop touching it.
Not dancing.
All right, introduce the video.
Welcome back.
Welcome back to where?
This channel.
What's the name of the channel?
All this math. Like, subscribe, comment, share.
All right. What are we doing today?
Math.
What type of math?
We're doing exponent rules.
Stop being facetious. We're simplifying expressions that involve the exponent rules. 2 examples. All right, read this first example.
Negative 4x.
Wait. Stop talking to the board. It's like when you're in class, you talk to your classmates. You don't talk to the board, right? This is like public speaking. Talk to the audience. These are people that are watching this all over the world. The world, Craig. The world. The world, Craig. Talk to them, okay? Talk to them.
Negative 4x.
Talk to them.
To the third power times 2x to the fourth power equals blank.
All right, so first thing you do is you're going to multiply the coefficients. You know what a coefficient is?
Yep.
A coefficient is a number that tells you how many of the variable terms you actually have. So how many x cubes do you have? You have a negative 4 of them. Not 2. Negative 4 of them. How would it be 2? The 2 is all the way over here. How many x to the fourths do you have? 2 of them. How many x to the thirds do you have? Negative 4 of them. How many x to the fourths do you have? 2 of them. All right? So you first multiply the coefficients. So that means Assata is going to multiply negative 4 by 2. Put your phone away. What are you doing? What do you think this is? This ain't recess. What's negative 4 times 2? What's the product?
Negative 4 times what?
What does it say?
2?
Coefficients.
8.
Positive 8. Really?
Negative 8.
Just say that. So negative 4 times 2 is negative 8. Now, when it comes time to multiply the variables have different exponents. Now, if we were adding or subtracting, we would not be able to combine these, but we can multiply them. All right? There's a multiplication property of exponents or a multiplication rule of exponents that you need to learn. All right? Focus. Put that away.
I'm focused.
Put it away. Now, x to the third times x to the fourth. You take the base. This x is called a base. It's a base. You write it 1 time. And then you're going to, when you multiply, listen carefully. When you multiply, you add the exponents. You add the exponents.
You need to back up.
You add the exponents. 3 plus 4. When you divide, you subtract the exponents. You add the exponents. What is 3 plus 4? What's the sum of 3 and 4?
7.
So that means that the final answer is negative 8x to the 7th power. Right? That's because if we were to write this out, look. Pay attention.
You all in my grill. You need to back up.
Pay attention. X time. Come back over here and watch. X times x times x times 2 times x times x times x times x. How many x's over here? How many?
3.
How many x's over here?
4.
So altogether, that's 7 x's. 7 x's. But it's not 7x because it's x times x times x times x times x times x times x. That means the exponent would be 7. That's why the multiplication property for exponents is like a shortcut. It's like a shortcut. All right? Okay, now let's look at this problem. I want you to read it to the people. Look at the board and then read it to the people.
6 to the 5th power over 6 to the 3rd.
Over. What does over mean? What operation is that? Okay. Now, conversely, you know that multiplication is the opposite of division, right? So if you add the exponents, when we multiply variables or numbers, they don't just have to be they have to be variables. We could do the same, apply the same rule with numbers, with constants, right? With integers, with fractions, with natural numbers, whole numbers, irrational numbers. What do you think we do when we are doing division? What do you think we do to the exponents when we're dividing? Yo, focus. Stop playing games on the whiteboard. What do you think we do when we do what do you think we do to the exponents when we do division? Answer the question.
What do you think we do?
You don't know how to multitask, so stop trying.
I don't know.
That's why you can't answer the question right now, because you didn't hear my question, because you was playing with your hands on the handprints on the board. What do you think we do then? Answer the question then if you heard it.
You divide the sixes by each other.
No. Pay attention.
Add.
No, pay attention. If you add, it's nothing funny. If you add the exponents when you're doing multiplication, what do you think we do with the exponents when we're doing division? Remember, multiplication is the opposite of division.
Multiply.
What the? Why would you multiply? If multiplication is the opposite of division, why wouldn't you do the opposite thing to the exponents that you do when you multiply?
Divide them.
Division is the opposite of addition?
Subtract them.
Yes. See what happens when you pay attention? Pay attention. Stop playing around. So look, you take the 6, right? They have the same base. Now, this only works when you have the same base, right? Are you listening? I only have an issue with paying attention. This only works when you have the same base. That's a 6 and that's a 6, right? 6 and 6, right? So you got 6 and 6. All right, so you write the 6 one time, right? And then you subtract. Just like up here, we added. We add when we multiply. Add when we multiply. Subtract when we divide. Yo, up here. Up here. Look over here. Subtract top minus the bottom. 6 to the 5 minus 3. What does 5 minus 3 equal?
2.
So the difference of 5 minus 3 is 2. So that's going to be 6 squared. What is 6 squared equal to? Is it equal to 12?
No.
Why not?
Because
what?
6 times 2, you multiply however many is in the corner by the number.
Run that by me again.
You got 6. You don't do 6 times 2. You do 6 times 6.
Why?
Because that's how many times you have 6. That's why the 2 is in the corner.
That's how many times you have 6. So also notice this. This is not how many times you multiply 6 by itself. A lot of textbooks say that, and it's wrong. It's wrong. Because look, if you're going to multiply 6 by itself 2 times, that looks like this. You start with a 6, multiply by itself once, then multiply by itself twice, once, twice, right? That's 3 6s. That's actually 6 to the 3rd power. I hate when I see textbooks that give that definition for exponents. I hate it. I hate it with a passion, right? If you see a textbook that says that, know that that's actually not correct. That's not official, right? So a better explanation would be similar to something Assata just said. The exponent tells you how many times that factor, that base, will show up in an expanded multiplication sentence. So if I wrote this out, because the purpose of an exponent is like to have an abbreviation, right? Because what if I got to multiply 6 58 times? I'm not about to write 6 times 6 times 6 and have 58 sixes. Nah, we ain't doing that. That's what we use exponents for. 6 to the 58th power, right? So this is 6 to the 2nd power. So that means we're basically creating a multiplication sentence where there's this many 6s. There's this many of whatever the base is, right? Just like up here. There's this many x's, 7 of them, 7 of them, 7 of them. So there's this many 6s, 2 of them, 2 of them. So 6 times 6. Assata, what's 6 times 6?
36.
36. And that's your final answer. Just like up here, negative 8x to the 7th power. So look, these are two very important fundamental exponent properties. The multiplication property and the division property. There's like 4 more of them that I got some other videos on the channel. Make sure you subscribe to the channel. I got some other videos on the channel that get into those. And we're going to still do more videos about those as well. All right. If Assata's lucky, she might be in those videos. I don't know. Depends on if she got a good attitude that day when I'm about to record them. But anyway, so look, so yeah, The exponent tells you how many of the base shows up, if it was in an expanded form, an expanded multiplication sentence. So 6 to the second power is 6 times 6. Oh, let me show you another. Let me show you something else real quick. Assata, watch this, right? So look, 6 to the fifth over 6 to the third. All right. So what if I had, so that's equivalent to this. 6 times 6 times 6 times 6 times 6. 1, 2, 3, 4, 5. Yeah. 6 to the fifth divided by 6 times 6 times 6. Right? So then I start to slicing and dicing. Boom, cross them out. Boom, cross them out. Boom, cross them out.
Wow, you got two left.
What's left? 6 times 6. Either way, we still get 36. So even if you didn't know the division property of exponents, the division property of exponents, you still would have arrived at 36. But it's good to know the properties of. She's at that age where she wants to act like she doesn't love me anymore. She's at that age. Yeah, she's 12, so she don't know how to act. You're not 13 yet. You're not 13. Somebody tell her and tell these kids to slow down. Like they shouldn't be in no rush to grow up because once you grow up, you're gonna start paying bills. You're gonna start doing adult things. Have more responsibility. You all right? Yeah.
Bye.
All right. Anyway, practice exponent rules, multiplication property, division property. See y'all later. Peace.